All right, lesson 4-7, transformations of quadratic graphs. By the time we are done with this lesson, we should be able to write a quadratic function in vertex form by either completing the square or using our formula of h equals negative b divided by 2 times a. And we should be able to describe and graph transformations of quadratic functions. Okay. Now remember, standard form, we have y equals ax squared plus bx plus c. And our vertex form is y equals a times the quantity of x minus h squared plus k. So the vertex in either case is always hk, and the axis of symmetry is always x equals h. Okay? And to graph, we need the vertex and two other points. So we need at least two other points. So sometimes you might need 4 other points. Now to go from standard form to vertex form, we are either going to complete the square or use h equals negative b divided by 2 times a. Okay. Now with quadratics, we can choose. Later on, we will have to know how to do this by completing the square, especially when we get into conics. Okay. So, but for now, you can pick which way you like better. Now, when we are choosing which one to use, we really want to look at the number in front of the squared term as well as the middle term. So if the number in front of the squared is 1 and our middle term is even, it's going to be pretty easy to complete the square. If it's not 1 and our middle term is odd, it's probably going to be better to find the vertex first and plug it into the vertex formula. Okay? So the first problem, it should be really easy to complete the square. So to do that, normally we would move our 2 over to the other side, but this time we're just going to move it further down the equation, and we're going to leave room to complete the square. So it's going to look like y equals x squared minus 10x, and then we're leaving room to complete the square. We still have the minus 2. Okay? And again, remember, we can't just add in any number that we feel like to a problem. Okay? So if we add a number in, and if it's on the same side of our equal sign, we also have to subtract it so that they cancel each other out. So I'm going to subtract it on this side. So again, when we're completing the square, we're trying to make that perfect square trinomial. So I'm always going to take the middle term, divide it by 2, and then square it. Okay? So negative 10 divided by 2 is negative 5. Okay? And then this part, we factor. And then the last two numbers we combine. Okay, so we will have y equals x squared minus 10x plus 25. Okay, so again, we are still going to factor this part. And then we have minus 2 minus 25. And we are going to combine the last two numbers. So the first 3 terms will factor into x minus 5 squared. And then negative 2 minus 25 is negative 27. So now my problem is in vertex form. So this would be the final answer. And just again as a review, the vertex of this would be positive 5, so the opposite of the inside number, and then negative 27. And our axis of symmetry would be x equals 5. All right, now the second problem, again, that middle term is odd. Now this wouldn't be too bad to complete the square, we would just have to deal with the fraction. So this one I'm still going to show you how to do it by completing the square. So same idea. We will have x squared plus 5x. We're going to leave room to complete the square. And then I also need to subtract that same number so that we're not changing the problem. So again, it's going to be the middle term divided by 2. So this is 5 over 2. And then 5 over 2 squared. So the first 3 terms we are going to factor. So this time I'm going to use our shortcut rule. So the first 3 terms when we factor, we'll factor into x plus 5 halves squared. And then this one, so 5 over 2 squared. So we'll have that plus 3 minus 25 divided by 4. So I need to combine. So common denominator would be 4. So now I will have y equals x plus 5 over 2 squared. And then multiply top and bottom by 4. So that will be 12/4 minus 25 over 4. And again, once we get that common denominator, we are just combining the top part. So this will be y equals x plus 5 over 2 squared. 12 minus 25 is negative, so minus 13 over 4. So this would be our final answer in vertex form. And again, just as a review, the vertex for this problem is the opposite of the inside, so negative 5/2, and then the k value is negative 13/4. Axis of symmetry is x equals negative 5/2. So again, that's a line that goes right down the middle of the graph. All right, the last problem, I'm going to use a different method. So I'm going to go through and find it using this h equals negative b over 2 times a. So to use this, we're just going to find the vertex, and then once we know what the vertex is, we're going to plug it into the vertex formula. Okay. So to find the vertex, we start with h. So h equals the opposite of the middle term, so negative 8 divided by 2 times a, so that's negative 2. So negative 8 divided by negative 4 equals positive 2. And then to find k, we're just going to substitute that in for all the x's. So negative 2 times 2 squared plus 8 times 2 minus 2. So simplifying, remember, we do the power first and then take it times whatever's in front. So 2 squared is 4, times negative 2 is negative 8. So plus 16 minus 2. So negative 8 plus 16 is 8, and then minus 2 is 6. So this is going to simplify to be 6. So that means for this problem, my vertex is 2, 6. So now I'm going to take this, and I'm going to substitute it into the vertex form. So remember, it's y equals a times x minus h squared plus k. So we found our h and k, and then our a comes from whatever number is in front of our squared term. So we're going to have y equals negative 2, because that was our a value in standard form, times x minus, and then our h was 2. So if this is negative, then we put a plus in here. And then our k is positive, so this will be plus 6 on the outside. So again, this would be our final answer in vertex form. And for practice, the vertex would, we already have the vertex, so vertex is 2, 6. And the axis of symmetry from that would be x equals 2.